of Mysore. And the second session is by Dr. Sargu Srihari, Sunny Distinguished Professor in the Department of Computer Science and Engineering at the University of Buffalo State University of New York, USA. In the first day of the session, the speakers concentrated on encapsulating documents as big data and driving into the application, which well suits the present scenario of academic institutions planning for online examination and authentication of documents. Today, with two eminent professors, we shall be understanding the process of converting human intelligence to machine intelligence in building thinking machines for a better world with automated technologies. For the first session, we have with us Professor D.S. Guru. He was the professor of computer science at University of Mysore, but sir is at presently at NIMOP, Bangalore as senior research assistant on sabbatical from University of Mysore. He is a recipient of Boyscast Fellowship and ARP Awards. Sir has over 360 research papers in various conferences and journals. He is also an associate editor for journals of patent recognition, IEEE, and Elsevier. Over to you, sir.
Good morning. Good morning, Madam Sahana. Thanks for this opportunity. I'm audible. Am I audible?
Yes, sir.
Okay. Thanks for this opportunity. So, is it my camera set up properly?
Yes, sir.
I cannot see my video here. How can I see my
video? Corner, right corner. Right corner ಅಲ್ಲಿ ನಿಮ್ video ಬರ್ತಾ ಇರುತ್ತೆ, sir.
No, nothing is being displayed here in the right bottom corner. No, you're talking.
Yes, right bottom corner.
Video is not on, but can you see my video there?
Yes, we are able to see the video, sir.
So fine.
Because it's full screen ಇರೋದ್ರಿಂದ ನೀವು ಹೋಗ್ಬೋದು ಸರ್. ವಿಡಿಯೋನು ಕಾಣಿಸ್ತಾ ಇದೆ, PPTನೂ ಕಾಣಿಸ್ತಾ ಇದೆ.
Excellent. So shall I share my?
Yes, sir.
So content.
Is it fine?
Content. Content upload. Yes, sir. Slideshow.
Is it good?
Yes, sir.
Okay. Good morning to all. It's my immense pleasure to talk about my little experience which I could gain because of wonderful research work carried out by my dozen of research students for the last 20 years on the field called artificial intelligence and bringing it in reality. And I also take you through a couple of use cases which I could work with my good colleagues in Nanotechnology Bangalore when I am on sabbatical position as senior research scientist. So the interest of this talk is let you know the opportunities and challenges, especially for I don't prefer calling anybody as a data scientist, especially for the people who have been pursuing their career and also for the people who have been working on AI-related research productization. So as I said, my interest is just look at various applications, domains, and niche applications and domains. What are the openings and what are the real challenges for both academicians and also for industry software developers. So throughout my presentation, perhaps you may observe that I will talk about only the things which we could explore for the last 20 years, and I don't introduce any new altogether a problem which you can think of taking up for a PhD in a strict way by getting you the objectives defined. However, I touch upon various potential areas for budding technocrats to further explore to make the artificial intelligence based solutions a reality, especially in Indian scenario, the difficulties in deploying such working models in Indian scenarios. How we have been, studying the AI techniques for the last roughly about 50 to 60, I mean 5 to 6 decades. When I was doing my masters, we had a course on artificial intelligence, and later on, what we today call it as machine learning, data mining, whatnot, deep learning. Those were also there during that period, but we used to take it up as pattern recognition, pattern classification course. The terminologies are same, but the scenarios are entirely different. So during the time, way back in 30 years back, perhaps we were talking about data classification, data pruning, knowledge discovery, and data processing, data clustering, whatnot. Everything, same terminologies, but the dimension, the size, altogether matters today. So, friends, if we begin understanding what is actually an intelligence and what is natural intelligence and then what is artificial intelligence, probably I would love to simply end up saying that an ability to solve a problem. In order to solve a problem, one has to have capacity to learn and acquire big knowledge, a great knowledge. It's not good enough to be a knowledgeable person, but ultimately we have to end up being an experienced personality. In order to be an experienced personality, one should improve the competency in using that acquired knowledge and skill for the right purpose at right time in a right way. So, such an ability to integrate different components of knowledge in the mind to make sure that the system altogether works for the specific domain is what is called a real intelligence. So then, generally, when we recollect our ancestors' civilization period, the people were so good in not only leading their life but also helping others. So, I mean, the person or a man wanted to have a support from other people. And later on, he has realized, why can't I think of a support from animals, which are generally called domestic animals? When he attempted to train domestic animals for his purpose, for a specific purpose, then he has understood that no animal could be trained well in a general purpose. However, every domestic animal could be trained, could be given a wonderful training to see that that animal can be dedicated one for a specific application of his interest. Perhaps look at the pictures. You may see here on the left top, the animals like oxes are generally trained well for the purpose of cultivation, and the animals like dogs are given wonderful training. Even today, the police departments, is using well the support of animals like dogs for the purpose of finding a person who committed a crime, for the purpose of security, especially in residences. And then look at the top right corner, you see animal, specifically donkey, which was trained well for carrying goods from city to city, from location to location. And then the next picture, you see animal called horse, which is personally tailored, which is given a specific training for the purpose of riding, I mean transportation. I mean, what we have understood, even if these animals possess a kind of natural intelligence, but unfortunately these animals cannot be given good training to make use of their services for in a general purpose. So every animal could be trained well for exploiting their strength and power for the purpose of only a personalized, specific domain applications. That's what is. I mean, today that during civilization, the people were talking about training animals, but today, because of the technological changes, developments in technology, engineering solutions, we are talking about personalized computing entity. So when I took my education into computer science, we were talking about general purpose computers. But today, gone are those days when computers were used for general purpose, but now the computers are given specific time. Computers are now becoming smarter and smarter for a specific domain, for a specific application. Today we talk about computers dedicated for surveillance application. We talk about computers dedicated for X-ray analytics. We talk about computers which is specially designed for face recognition, attendance taking, and so on and so forth. I mean, what I am indirectly telling that, especially when we move from this natural intelligence reality to artificial intelligence, then we are going to identify computers for a specific domain. What the domain is, then we must have a domain knowledge, and we must have we must collect a very huge amount of data to give such a training to the computers. I mean, computers have got to be trained as if human beings are trained. In such cases, what really matters is artificial intelligence. Artificial intelligence is an ability of a human being, of course, to make computers exhibiting intelligence. The moment I make my computers capable of exhibiting intelligence, then I say computers have been given an intelligence, but not natural intelligence is an artificial intelligence. Any simple programming, you just check if computer can decide if given number is a prime or not on its own, then I say computer exhibits kind of intelligence in verifying whether number is prime or not, right? If computers can, solve a quadratic equation, end up producing two roots, then I understand that computer knows how to solve quadratic equation. And such an ability of a computing system, I mean, programming aspect of computing system is generally called as an artificial intelligence. But today, the terminology called AI has been taken to that extent of making computers learn on itself. Is not that I have to program how to check whether the given number is prime or not. In case if I give a collection of numbers, I mean, let's say thousands of numbers or two thousands of numbers, lakhs of numbers, and bifurcating them, couple, some of them as non-prime and some of them as prime, and then I want computer to look at this data collected and bifurcated into two subclasses called prime class and a non-prime class, and automatically understanding what is the differences between these two subclasses, and over the elements in a single subclass are related, and over the elements in another subclass are related, what is the relationship existing among the elements within subclasses, but what is the discrimination between the elements of two different subclasses. If computers could be made so intelligent to extract such a beauty, such a strength of discriminating a prime from a non-prime, then I say it is something beyond simple programming aspect. It is what is called system learns and machine learning. Look, the artificial intelligence is, of course, considered to be a programming of a computer to simulate or mimic human intelligence. Ultimately, it is an algorithmic thinking. So there were sorting techniques, searching techniques, reasoning, planning. Basically, whatever you solve, or however you call it as a data science related problem or artificial intelligence related problem or what not, whatever you do in computers is basically fundamentally a searching problem. Probably in subsequent slide, I would present this machine learning from a fundamental science aspect that is basically a searching. So AI concentrates on coming out with the expert system. I mean, ultimate job of AI is to make my computer more personally tailored computing technology instead of being general purpose computers. I mean, one way of making system instead of ultimately use it and programming it, if computer can learn on its own, the way in which I explained, how computer can pick up the knowledge on, discriminating prime numbers from that of non-prime numbers is what is called machine learning. I mean, computers are allowed to learn. Computers are given training, and that's what is called machine learning. Machine learning is an approach to achieve artificial intelligence. It's simply an approach. I mean, artificial intelligence, in my opinion, is bigger space, whereas machine learning is a subset of it. Is a smaller space of it. It is a method of accomplishing the artificial intelligence. It's a method of inculcating ability of solving problem into a computer. I mean, I allow computer to learn, learning to learn, right? That's what it could be a pattern classification, could be for the purpose of clustering of patterns, looking at the likelihoodness, and so on and so forth. I mean, the moment you go for machine learning, the computers which were so-called personalized, they become more specialized now with respect to a domain application. And how do I achieve this machine learning? Then what today is dominating, today demanding technology is what is called deep learning. Deep learning is a powerful teacher to make sure that system learns to accomplish machine learning. Machine learning is to accomplish AI, whereas in order to accomplish machine learning, we today have got luckily a deep learning, a powerful teacher. Deep learning has been successful in industry. Deep learning has been successful in engineering applications. Deep learning has been successful in academics, whatnot, in technology in general. So such a powerful teacher which can teach better computers so that computers become self-learning entities day by day is what is called deep learning. So, dear friends, my interest is before I get into the opportunities and challenges of AI in making AI a reality today, before that, I just want to give a fundamental science behind machine learning and setup of machine learning. So in machine learning setup, basically we have four different components. One is a sample space, an input space. Input space could be a collection of images. Input space could be a collection of text paragraphs. Input space could be a collection of wonderful lectures, audio, delivered by a speaker, and so on. I mean, input space could be an image of size 100 by 100, totally of 10,000 different pixels. I mean, the input space has got about 10,000 dimensions. Let it be n in general. I mean, we have got sample of instances, I mean, of various patterns or various activities of your interest, which are grouped together under what is called input space. On the other end, we have a label space called output space. For every sampling in the space, there is an expected, a label space, and probably that label could be given as a picture, whether it is a cat or not a cat, right? Then the label could be a +1, label could be -1, it could be 0 or 1, or it could be given as a picture. Does it contain a face of a person? If there is a face of a person, who is that person amongst the k persons whom I know? Then it is a recognition of a face in a picture of size 100 by 100. Then there could be k number of labels, k categories could be the outcome of it. This is the second component. The third one in the machine learning setup is a distribution which is generally unknown from input space to output space. I mean, we have a certain mappings of these input samples onto corresponding labels, and such a distribution is, because this collection nowadays happens to be too huge, understanding the distribution itself is a tough job. So this is what XY pairing, So that's the third component. The fourth component is the loss function associated with this estimation. I mean, ultimate job of a system to predict what is supposed to be the label Y associated with a given input sample. So then we have a loss function. The loss function means when estimated labels deviate from the actual label, there is certain differences. You just calculate using Euclidean norm, or I mean L2 norm, and estimate the loss. And that is what is called the penalty that one has to pay by deploying the system in a reality. So that's the third one. So look at the fourth one is that loss function. I mean, one is a sample space, the other one is a output space. In between, we have a distribution and unknown, generally a very used distribution, and fourth one is a loss function. The task of a machine learning is given some pair xy. I mean, given is input and output mapping. Given is this input and output mapping for some pairings, not necessarily that all, but for some pairs. So predicting a hypothesis, predicting a model which can establish such a mapping from x to this y with by minimizing or by optimizing the loss function L. I mean, ultimate job is to search for a hypothesis in the hypothesis space. The hypothesis space is a possible, collection of all possible potential solutions, which functions which can map a given x onto a y, and looking for the model which best suits my mapping from x to y is what is called the task of machine learning. You are given some in x cross y and predicting such a hypothesis, a member of that possible space H, which is a collection of all possible solutions, is optimizing. I mean, I got to reduce, I got to make sure that this L is as minimum as possible. And that is what is called machine learning. So in this machine learning setup, basically we have a search space, though we expect the search space to be as complex as y power x, but we don't go with all possible ways, but we just restrict ourselves with a certain constraints. That's what is called a space called hypothesis space. So if you restrict this hypothesis space, you will have more approximation error, right? So probably in this space called search space, we expect this to be the ground truth hypothesis. This is what is actually the mapping function, the model which best suits my mapping from x to y. But unfortunately, when I define the hypothesis space, that hypothesis space may not cover this HG, the ground truth hypothesis. Then you end up finding out, estimating something which is not necessarily this ground. but this is what is empirically expected to be more optimized. But most of the times you don't end up with that most empirically optimized one, but you just end up computing something which is closer to it, right? So that's what is called computed hypothesis. When the computed hypothesis, so look at the error between this ground truth and the optimal hypothesis in the hypothesis space is what is called approximation error. And the distance between this and the one which you really expect, empirically computable is what is called estimation error. And unfortunately, most of the time, because we may not end up with a global minima, global optimization, we may end up getting some other hypothesis called HO. Then there is another error which is called a training error. Look at, we have to optimize, we have to balance all these three different types of errors. One is an approximation in solution, the other one is estimation error, the one more is a training error. So this is ultimate job of a machine learning task. So if I just recollect the classical machine learning techniques, then I would love to say, because I've experienced a lot in classical machine learning than deep learning, which has, which have appeared recent in 5 to 6 years back. So because I come from such a classical machine learning background, I always love to speak little bit about classical machine learning as part of my presentation. So in classical machine learning, generally we work in Euclidean space, and we always, most of the times, always assume that our hypothesis space is a linear function. Most of the linear functions are always convex functions, and because of that, we express an output y as a linear operator, right? W is a matrix of k cross n. N is the input dimension, k is the categories we expected. It's a k cross n dimension matrix, a linear operator. When that linear operator is applied on is x unknown, then we end up generating the y, the label. That's what. But look at here, in case of least square regression, we approximate the samples by a linear line segment. In case of a decision tree ensemble, we do the same thing, and we put a cutoff, and anything which is less than that, we go with this, otherwise we go with this, and so on. Look at, everything can be expressed in the form of a linear function. So even in support vector machine, basically we talk about support vectors, and then try to optimize this margin so that I can maximize this margin, and then I try to fix up a straight lines, discriminator which maintains, equidistance between two classes, from both the classes. That's what. But thank God that later on, because most of the times the classification cannot happen only with the linear functions, and most of the boundaries are non-linear. In such cases, can we make that non-linear as a piecewise combinations of linear? Then what luckily came into picture is kernel functions. With the support of kernel functions, even if the samples are not discriminable from the point of view of linear functions or based on linear functions, can we think of mapping them onto higher dimension, mapping them onto a different feature space where classes become more separable and linearly separable, right? So look at here in this case, we have two classes, but the boundary separating those two classes is not linear, it is a non-linear. Then the job is to have a kernel function and apply the kernel function phi on these samples so that the samples get relocated, repositioned in a feature space so that the samples of both the classes become linearly separable. So it may be possible for you to think of a kernel function which takes you from n dimensional to n dimensional itself, which takes you from a space of some dimension to a space of the same dimension. But unfortunately may not be always possible. In such cases, think of reducing the dimension later subsequently, but by enhancing initially the dimension. Then you go from 2D, look at these red dots are mixed with this green dots, but unfortunately I cannot draw any linear segment separating these two classes. However, I can separate these red dots by drawing a elliptical shape so that that ellipse can discriminate all red dots from the green dot. In such cases, what do? Can I think of enhancing the dimension? Instead of working in a 2D plane, if I can map them onto a three-dimensional space so that I can think of a decision surface which separates all red from that of green. And that's what is the beauty of kernel functions. So with the support of these kernel functions, luckily we could develop such a classical machine learning. But look at the strength or the power or the complexity of your machine learning algorithm searching. So it's a searching. So basically I get to end up searching the most optimal solution here. So if you restrict your edge space, then you become most effective and efficient in searching. But unfortunately, yeah, you will have a higher degree of approximation error. So if you enhance the edge in classical machine learning technique, enhancement of edge of course puts you into more complex searching problem, but it will improve the approximation error. But at the same time, the moment you enhance this, edge, probably this edge may be of longer length. When this edge happens to be of or longer length, then you will end up with a more overfitting. The moment you go with the overfitting, then you will have less generalization ability. That is real bottleneck issues in machine learning. So on the other hand, today we talked about the deep learning. The deep learning, as I said, has been demonstrated to be more successful, especially in industries for various applications. So still, the deep learning works in Euclidean space, but the beauty of this deep learning is to work in a hypothesis space of higher dimension. The hypothesis space should be of as exhaustive as possible, so that setting up the weights in the neural network perhaps helps in going with hyperparameterization, and so that I can approximate that a non-linear boundary which is capable of separating classes of my interest. And that's what's the beauty of this deep learning. So in we talked about fully connected neural networks 30 years, 20 to 30 years back, and nowadays we talk about convolutional neural networks, really multi-layered neural network architecture, fully connected neural network is supported with a feature extraction mechanism through convolution operator. Look, in classical machine learning, it is our responsibility to check with which are the features which really describe well my samples, and which are the classifiers which work better when compared to other classifiers, so that I get to tie up. And ultimate model is a pre-processing, and then a feature extraction, and the classifier combinations, if any, and then which is the best sequence of this, which is the best combination of all this, that we have got to work on. But on the other hand, in case of deep learning, if we have a collection of inputs, samples, you just lead them, just give them as input, and see the system will learn not only the method of classification, not only method of fixing up a linear and a non-linear boundary, but also the which are the best features through convolution operator. So we have a recurrent neural network to take care of temporal information, right, and to preserve the sequence with the data appear, so that we can predict what could be the best possible data which comes in the sequence, and so on. So recurrent neural network, and especially for the last few years, probably from the year 2014 to 2015, we have a gallery of deep topologies: AlexNet, ResNet, InceptionNet, GoogleNet, YOLO for detection, SSD for detection. We have a gallery of different deep architecture, different deep learning topologies. Unfortunately, this has really put us into a confusion which deep network is supposed to be used. Right, look at, though I said in classical machine learning, the moment you expand the hypothesis, of course you will reduce the approximation error, but it results with a less generalization. But on the other hand, the beauty of this deep learning is if you go for expanding edge, it not only reduces approximation error, it also reduces the expectation error. So overfitting problem can be solved with the support of this. But unfortunately now, in the hypothesis space, H, I end up with several deep learning architectures, and every deep learning architecture has got its own limitations, especially the resolution of picture, which is supposed to be given as input, is considered, right? Then which is the best one? I got to study. But unfortunately, to study on every deep neural network architecture, I got to end up training on large voluminous data. But one thing is certain: this deep learning is a multi-layered networks for machine learning. It makes machine learning possible today. It is a powerful and efficient method of teaching computers to learn. So look, artificial intelligence enables machines to think like humans in general, whereas machine learning is training machines to get better at a task without explicit programming. I want the system to learn on its own, but I don't want to sit for a long time to program it. Instead, I just have data, I have mapping between data, I have unknown distribution, but I want the system to learn what is the distribution, the mapping from input to the output, and then how do I see that the system becomes so effective in learning? Then thank God today we have got a deep learning modality. So deep learning is an algorithm. As per Hinton's point of view, deep learning is an algorithm which has no theoretical limitations of what it can learn. There, however, the more data you give, the more computational time you provide, the better it is. It learns better if you can spare your time, if you can give more data. Look at here, what is really challenging today is how much is the data really required to train my model and how much time I'm supposed to spare, right? But today, as far as architecture, computer architecture is concerned, we have moved from CPU to GPU to FPGA, right? So the computational power may not be an issue, but the cost of that computational power is really an issue today. And of course, the data, where do I get data? Who is really capable of providing me the data of my interest? Huge amount of data. How do I get the data? What are the real challenges? How do I go to field and collect the data? Do you think that everybody is really in support you to give the data? These are all the challenges. But on the other hand, you being a person exploring in the field of artificial intelligence, you have to make up your mind, take it as challenge, and go and look for an opportunity to get your own domain solved so that you can deploy the system in real environment. So data quality is a problem today. So not all data is completely clean data. Data is never clean. So more time is spent on cleaning and preparing, right? You have to spend a longer time for cleaning the data that you collect, preparing the data. I recollect even today that a couple of my students, especially in recent years, I know have a student named Sumitra who has been placed on a project called, studying longitudinal face data of children below the age of 10 years. And think of coming out with a kind of hypothesis which can explain us when can one deploy a biometric face recognition system for children, right? When does the biometric system, face recognition system especially, become stable? When it is deployed, when it is employed on faces of children. And she has really put in a great effort, but unfortunately, because we wanted to stay a longitudinal data, so a period of 5 years is not good enough to make a study. So that is what is the data quality. That is what is the difficulty in coming out with the data. So data quality is very important. Data quantity, how much, how many individuals I got to meet with, how many face images I got to collect, what not. It's not that I have to infer only based on a small amount of data. In case if you want to generalize your solution, you have to have more observations. In order to have more observations, you have to end up collecting. So look at you being a data scientist, you being a man working on related aspects of artificial intelligence, should never hesitate. Getting into the field, should never hesitate. Meeting with the people, should never hesitate. Talking with others and get the data. So while getting the data, make sure that the data quality is really good and quantity wise is also acceptable. And once, of course, most of the times you may collect the data, you end up collecting the data. So I recollect here at this junction, the effort put in by my PhD student, Dr. Jyoti, who went on, and Dr. Sharad Kumar, who both went on collecting data on varieties of flowers, flower species. They have collected, so many images, so many videos of flower species of roughly about 100 plus different species. So, of course, they ended up collecting videos of various flowers, videos and images of various flower species. But now we are not the domain experts to label them, which are the species, which are, samples of same species, which are the, videos of same sample, same species, and so on. Then we used to approach a domain expert about only. But botanist may not be available always, and even if he is available, he may not be with such a great interest to help us, right? But somehow we are going to beg, we are going to request. So meeting with experts, that's another challenging issue, especially for computer scientists, the AI experts, right? Data labeling, I like to get the data properly labeled. Unless you get them properly labeled, you may not end up with a ground truth. If you don't have a ground truth, then no question of estimating the last function. The last function estimation itself becomes false. Then you cannot expect your hypothesis to be so good in modeling your input output mapping. So data explainability, yes, of course, I end up extracting features from the data samples, randomly extract. I talk about HOG, I talk about some other descriptors, whatever. But how relevant those descriptors, especially for explaining the relevancy of my data. So data bias. What is the guarantee that there is no bias in explaining and describing the data? So that we have got, I mean, feature engineering, feature analytics, that we have got to study well. And then data privacy. Of course, I collect the data. I just deploy a system working in a real environment. Especially, you can imagine, a shop, a mobile, selling shop, where person will go and buy a mobile, and then if the same person goes to the same shop next year, then system will identify him and suddenly say that, oh, welcome, Dr. Guru, you visited last year. Is there any problem with the mobile? But I must not have told, my family members. I have visited that. I must not have told my good friends. I visited that shop earlier last year. I got another mobile. Now I'm getting into the shop again. Then what is the confidentiality? How do I maintain that? So data privacy is really a problem today. And not only that, look, AI lies in technological side. I'm happy with the AI because I know the in and out functionalities of AI, but unfortunately, the people are not aware of it. How to build trust? The people do not accept that. Just because, just imagine a problem of what an AI is deployed for the purpose of automatic gate opening. So I just see that it is deployed in my residence. Then if somebody comes, then automatically the door of my residence gets opened, assuming that that person is familiar to the family. So let's assume that we have trained the system to understand the faces of all the people, who are good friends of mine. And then, can I really believe that the technology works fine and opens the door of my residence only when a person who is familiar to my family tries to enter? Even if 1%, even if 0.001% goes wrong, then I will be in a difficulty. How do I believe? So then I get to think of an AI system which explains, which reasons out its own intelligence. The way in which I explain this, why I have taken up this is a decision. Look, current existing AI technology just end up giving the labels of the observation same, but why the AI has made such an observation, that's quite interesting. Then explainable AI as coming to picture, that we have to look at that also. Investment, because it's too expensive technology, then no businessman, no business owner, no business manager is coming forward to invest so big amount for the deployment, for the development of this AI technology. And the question is, are we thinking of AI as a complementary tool or a supplementary tool for human experts, right? Obviously, please take it from me that we are not looking at AI based solution as completely a complementary solution, but a supplementary solution. I mean, we have got to work along with that. So if I have got to work along with, in spite of that AI technology is deployed, what is the necessity of having AI technology? This is the common man's question. We have got to answer. So every common man has got high expectation because not all of them know how does AI function, right? So always there is always a gap, expectation gap. There is always a gap called semantic gap. The user expectation is too big, but the technology can provide to some extent. And understanding that gap and bridging up that gap itself is an opportunity for AI scientists today. And while addressing such a gap, bridging up such a gap, of course, there are many issues which come all along with you as challenges. Remember that most of the tasks do not require deep learning, though deep learning is demanding today. And suddenly everybody thinks that given is the task of machine learning, I'll go with the deep learning. Even the task is, I got only 5 people in my residence. I am going to think of a mobile application where the mobile is used as a supplementary tool for my television, so that the mobile has to recognize Guru has come into the living hall. Then television should switch on and display only the news channel. And Guru's son, who is really a child who has come in front of the television, then suddenly mobile has to understand that his son has come and he prefers to watch international cricket game. The television has to switch over to the channel of international cricket game. Then just for recognition of only the faces of 5 individuals in my residence, suddenly I think of a deep learning. Unfortunate. This is the mind setup of people. Always we think of deep learning. Dear, just understand that most of the tasks do not require deep learning. Deep learning is not the always possible solution for most of the applications. There is nothing like fully automated. We have to think of semi-automated most of the cases, and all models are not true. Most of them are false, but still some are really useful. And which are all those useful deep learning architecture for my specific domain and so on? That is really challenging. One has to study well, and then faithfulness on outcome of AI tool, especially what I said, building trust on people. So that's what is called explainable AI. So if I just touch upon what is explainable AI and science behind this explainable AI, it is AI within AI, right? AI can think. I want AI to think on its own and then reason out for its own decision. I mean, deep learning architecture given as an input, it generates the label here, the class label. But what is the reason why that deep learning architecture has ended up with this class label? Can I think of taking up some intermediate inferences and combine them together and generate some explanation about it? So a teacher evaluates the answer scripts and end up giving 7 out of 10. Then the class label is like 7. But I want to know why the teacher has evaluated my answer for 7 out of 10. That teacher is in a position to explain why the 7 is given instead of giving 10 out of 10. And such explanation is expected to be also all along with the class label from this deep architecture. I mean, I want to move local to global learning. I don't want to end up just learning altogether, but I have to understand every piece of learning, every stage of learning, right? Deeper and deeper you go, probably you will have a tendency of forgetting every local aspects and end up only generating inference for the entire global. But I want to remember even the local, and based on the inferences derived at each stages, can I think of merging them together and come out with a kind of explanation all along with class label getting which gets generated. And that's what is called reasoning my own judgment. That's explainable. Yeah, explainable is another branch of artificial intelligence today. You can explore many interesting challenges, and you have great opportunities, especially for moving toward this explainable. Yeah, explanation could be in the form of image. Explanation could be in the form of numbers. Explanation could be in the form of text data. The generating the text data all along with the class label, so that it is as good as a human being standing in front of me and evaluating my answer script 7 and also explaining me why 7 is given in terms of English text. So that's quite interesting problem that one can think of exploring. So looking at the opportunities and challenges due to this COVID-19, especially for AI technology, dear friends, for the last few months, 3 months, as a part of NIMO Technology of Bangalore, and all along with my colleagues from the data science team of NIMO Technology, we have been working on various use cases. Out of them, I wish to present some of the use cases here related to the opportunities which the NIMO got and the challenges we face because of this COVID-19, keeping in mind AI-based solutions. Face recognition system. So we have deployed a wonderful face recognition system which was capable of recognizing thousands of faces, thousands of individuals for an organization. The system was well deployed and it was well used by people, and the organization people used to enter into the campus, and the system used to record their attendance, system used to identify the people. And for that we just have used deep learning and extracted 128 features for each individual phase. And for every individual we just have taken 3 different views of a person. For each 3 different views we generated encodings, 3 different vectors of size 128 features, and we just have stored them as part of libraries. So if there are, let's say, thousands of subjects, thousands of people, we have got 3,000 of factors stored in the library. And whenever a person comes in front of the camera used to capture. It's a real environment I'm talking about. So there should be a tablet, and tablet the face is given. This is in case of attendance. Or it could be a surveillance camera, a man coming in front of the surveillance camera. The camera used to capture the face and identify, detect the face, and crop it up to some size of, if I remember, 90 by 70, and extracting 128 features and matching against. The system was really deployed well. But suddenly, because of this COVID-19, situation, the people started coming with mask. Unfortunately, system went completely wrong. So system must now work with faces, work for faces with mask. What is the problem now? Almost 50 to 60% of the face is completely blocked. And if I end up extracting these 128 features, probably these 188 features get deviated, because in our convolutional neural network, entire face image is given. So then the convolution happened for the entire plane of the image. It's not that local descriptors are extracted and stored. It's that the entire face image is completely convolved, and these 128 features have been expressed as functions of all these 100 by 100, let's say 10,000 pixels. I mean, every feature here, every one out of 128 is a function of all these 10,000 values. But unfortunately, the moment the part of it is completely masked, completely blocked, then we end up extracting altogether a different 128 features. Then the question is, if a person is with a mask, probably first we have to retrain our model so that the system should be able to detect the face of a person even if he comes with a mask. A face detection itself becomes a problem. Now somehow you could tackle it, and detection of face even with mask is possible. And then once a face is cropped and there is a mask area, and then detecting mask, whether the face has a mask or not, that's a two-class problem. I mean, first up is given is a scenery, an image where there is a person coming in, just crop the face area. The face area cropping is what is called detection of face. That is happening well, because earlier we used to have faces without mask. Now people started coming with a mask. The problem now is to detect that face with a mask, even if there is a mask. And then once the face area is cropped, then we'll have to verify whether that face is with a mask or with no mask, right? So that's what is called mask classification. So look at here. Here is a face of a person, trained well, right, without wearing mask. But now the person comes with a mask. It is digitized. It's we have synthetically generated. That's not the original, face of a person with a mask, because we not to train the system. We cannot expect now the people to coming in and give their faces with mask so that we can retrain our model. So suddenly, all of a sudden, X comes in front of the camera, but with a mask. Now we have to make sure that by the time lockdown period is over, the employees started coming into our office, we should see that our system even becomes so robust in taking care of recognition of people with mask. But the system was trained with faces without mask. That's quite interesting here. Then we conducted some experimentation, and then we just have designed a model which is capable of fast verifying whether the face is with a mask or without a mask. If it is with a mask, then the task is to recognize who is she, who is that person. Then can we think of finding out the best subset of these 128 features? I mean, the problem now is to design a filter strategy, a filtering of features, so that filtering requires ranking of these 128 features, and amongst the moment those features have been ranked, then selectively choose the top ranked features, so that I will have a better accuracy in recognition. So that's what is called feature subsetting. When we attempted, let me just also present a part of the result. Look at here. Here is a face without mask, but now suddenly that person comes with a mask. Here is a face without mask, but suddenly the person comes with a mask, right? Mask of different color, mask of different shape, mask of different nature, and so on. Look here, the person has the face has been given to the system with such a nice photograph, but the person, because of COVID-19, even if a person comes without mask, but there is a bad this is a real difficulties. In addition to that, there could be a mask. Then the problem now we have to authenticate the face looking at only this visible area. Then the question is, because 128 features have been extracted looking at the entire face here, now which are all those subset of those 128 which are responsible, which are capable of describing only this area of the human face? And that has got to be studied. And that studied by exploiting different ranking criteria for filtering design. And for the sake of presentation, I just added up here on 4 plus fusion of those 4 different rankings. We just have conducted some experimental results. Here is presented only for 173 individuals, 173 with face without mask 173, corresponding images where mask is synthetically generated. Totally we have about 346, and number of features extracted, as I said, 128, and number of matches when all 128 were used, look at 81%. But when we attempted with the different ranking measures, ranking criteria with mean, and what we have done is a simple, we have one sample each, we have one sample each. So take up 128 vectors here, 128 features, 128 features, and calculate the difference feature wise, right? We ended up in calculating one difference vector for every individual. So we have got about 173 such difference vector. So then study the what is the feature which has got less discrimination between the original and the mask one, right? So then I'm looking for a feature which has got that less distance, less difference. So then when we use that entire mean of 173 as a property, as a criteria to rank, it turns out to be about 90 point something, and mean difference, a minimum among those differences, the feature which has got a minimum difference amongst all 128 is chosen to be the top one, the next one, and so on. I mean, the features have been ranked based on this min difference criteria, based on variance criteria, based on max difference criteria, and so on. Look at this, these are the accuracies. And when we just have fused all these rankings together, I mean combined, taking up the combined ranking and then averaging the ranking, then the system started working with 92.48. There is a considerable expansion, there is a considerable improvement reckoning in the accuracies. So this is with, and then we just allowed the system to work in a real environment, and then for about 9 individuals who started coming into the office, the system exhibited about 100% accuracy. So look at that. That's where the COVID-19 has really put it into a difficulty environment. Right? We cannot expect the people to come and give their faces with mask and again re-enroll and so on and so forth. So then, can we think of some alternative models? This is what the model which we explored and thinking of deploying now. But now, what can we think of some other ways of solving this problem? One can think of designing a convolutional neural network again to map both encoders of face without mask, encoders of face with mask. Look, already you got 128 features generated. Now take a face with a mask and get the 128 features generated. Now I want these both encoders, vectors of 128 features, to be mapped onto the same encodings later subsequently. Then can I think of another convolutional neural network which take this encoders 128 feature as input and generate some encoding of 50 or 20, whereas again it takes the same 128 dimensional vector of encodings of face with mask and generating the same 20, so that if not exactly the same 20, so the difference in them, the loss in them, is negligibly small. That could be an alternative way of exploring. I mean, a network following a network, outcome of a network is given as input to the next convolution network, so that second level mapping is possible. I mean, if a person now comes with a mask, what you have to do is, already you got this second CNN deployed, and 20 encodings have been generated. Now extract 128 basically, and then feed them into this new CNN, and let this new CNN generate another one, 20 encodings, so that these 20 encodings will be matched against those already generated 20 encodings for existing 128 encoding. This is one alternative model. So another alternative could be, why can't we think of, look at, here is a person, a face without mask. Can we think of only cropping automatically only the area which is uncovered, even if there is a mask, only the area which is not covered by the mask, and generate 128 vectors, for example, right, encodings. And then when a person comes with a mask, try to identify only that top area of the face and generate 128 vectors. So I mean, what already existing, what we have already existing faces, we are going to generate 128 encodings in two different ways. One is, because I'm not sure that the person tomorrow comes with a mask or comes without a mask. Let him enjoy with the freedom either to come with a mask or not to come with a mask. But now what I have to do is take up all those images which we have used for training purpose and locate the top region and get the another 128 vectors generated. So now we have two encoding, two vectors of 128 dimensions. One vector of 128 dimension represents the entire face without mask. Another 128 dimension vector represents only the top area of the mask, when face is with them, top area of the face when faces with the mask. I mean, now for every individual face sample, we have two encodings. When if a person comes with the mask, then try to detect. I mean, if person appears, then detect the face and check whether that face is with a mask or not. If not with a mask, deploy your CNN to extract 128 pitches, looking at the entire face area, and then match against the respective encodings here. Or if a person is with a mask, detect it and look at the top area, eye area, generate 128 and get them mapped again. This could be an alternative model which are still being explored in our NIMO technology. NIMO technology is a very specific industry which is concentrating on visual analytics based solutions for most of the domain applications. So some more are interesting applications and challenges related to face features. So selectively choosing the best views in real time. I mean, I have a surveillance camera. The people are starting walking in a corridor. You can think of a big institution where students are walking in a corridor. I get to recognize students. If I want to recognize student, then I get to selectively choose the best view of those students. So in real time environment. That could be an interesting, challenging job, especially for budding technocrats to make their reality working in real time, real environment. Gender classification, age estimation of a person, this gender classification, associating a face with the gender, associating a face with the ages, age estimated, so could help a lot in support of near search. I have got a large collection of individuals. So, like Manasa Gangotri campus of University of Mysore, I want to recognize people, the students of Gangotri. There are 10,000, there are 18,000 students studying in campus. Now, how do I recognize every individual, right? So then if I can classify them based on gender, then the recognition problem can be a subset facing, face subsetting, and then think of deploying for, one model for female recognition, one model for male recognition. Within that female and male, we can think of bifurcating further and further so that the matching criteria becomes, not that complex and works much faster. So these gender classification based on facial information, age estimation based on real environment I'm talking about, keeping in mind surveillance applications. And day before yesterday, I mean, the last lecture, we heard of Professor Nagbhushan talking about online evaluation. I mean, a completely computerization of evaluation of answer scripts, right? Okay, so that's quite interesting. Today, look, I'm sitting in my office and delivering a lecture, online classes. But what is a guarantee that all people who are enrolled, who are registered for my lecture today, are really alert and listening? Look at in conventional classroom environment, teacher is so accountable. Teacher can monitor the progress, alertness of every individual because there is a eye to eye contact. But unfortunately, here I'm not in eye contact with every one of you. So then unfortunately, on the other hand, look at every one of you have got a system with a camera. Camera is looking at, if not me directly, virtually I'm looking at you. Can I think of building up an AI system which can monitor? I mean, in every one of your individual system, there is AI tool working and capturing your continuously your faces and looking at your faces, predicting the gesture on your face and coming out with decision making, how long you are alert, how long you really enjoyed lecture given by a speaker, right? So are you happy with that lecture or unhappy with the lecture? The way in which the teacher monitors this, students understanding in a classroom. Can I think of in online classes also exploiting the beauty of this AI technology so that the AI technology would help the teacher to assess the students in their accountability of attending the classes? That could be a wonderful, interesting opportunities for budding technocrat, and also has got many challenging issues. Look, DS, this BNMIT people have got such a data collected now. So there are about 800 participants, and everybody's video is being shared. And now you end up collecting, by the end of my lecture, you end up collecting 90 minutes videos of 800 people sitting in front of the system, and some of them are missing, just a logged into the system, but must have gone out and may come after 1 hour, may come after 30 minutes. You can monitor it. And I ultimately, by the end of my lecture, after 30 minutes of my lecture, I want such inference. I want the dashboard to be displayed where these many people completely attended the entire 90 minutes lecture, and so many people. I want a kind of histogram representation of the overall environment of this online delivery. Can we think of such a technique today, right? This is really an opportunity and a challenging issues for budding technocrats. So look at, as part of COVID-19, the NAMO as a part, also worked on some drone pictures, drone cameras captured to generate instantaneous alerts whenever the people are not maintaining social distance. I mean, whenever we end up seeing the people violating, social distances. So this is the input stream. This is a live stream we worked on, right? This is a live stream. The drone camera live, stream is given. Then the system has to detect vehicle. System has to detect people walking around, and then estimating the distances between them, and then finally telling that there is a violation of social distance. Please look at this video, right? Okay, so there is a violation, a social distance violation. Suddenly alert should rise, should appear, and should send it to the police departments, and so that the police van will come to that specific area where drone is being run, and taking care of this, and so on and so forth. This is a real challenging issue. But here, most of the times, the problem in solving this domain application is lies in trackers. Most of the times we end up losing the trackers. So, and identifying the same person as a new person, right? Identifying the same vehicle as a new vehicle, and that's what. So another interesting problem is called cough. A person may be coughing. That's quite very important for the COVID-19 warriors. And if they happen to see anybody coughing, then they catch hold of him and takes him to a COVID-19 hospital. Then how can I think of deploying a surveillance camera where camera will continuously monitor people walking around, and then if anybody ends up coughing in between, should be taken care, right? That's what another problem which we also worked on. So these are quite interesting, real time and making AI reality. So natural intelligence has proved its own, and it's not that the human individuals have started possessing natural intelligence. Later on, we just have inculcated our natural intelligence into animals, and animals are personally tailored, given specific training. But now we are talking about this. Can we think of inculcating such ability into computing systems for a specific? This is into crowd detection, right? So given is an environment where people are moving around and there is a surveillance camera set up, and can we detect if three or more people are moving together? I say it is a crowd. Or four, or I mean, identify the people, count the number of people, and calculate the mutual distances, establish a clustering of people in this 2D plane, right? And then decide whether it is a crowd or not a crowd. If there is a detected crowd, then see that the system will generate sudden alert, and the people become aware of it. That's so crowd dispersed, crowd formed, etc., and so on. This is, and ultimately I get to make this AI tool working in real environment. So the speed at which it works should suit the speed with which we move across, right? So other challenges could be taking up attendance of employees of a retail shop at entry gate itself, right? That person is entering. While entering itself, I want attendance, right? So then is at a entry, that's an activity detection, right? Detecting faces with the background light is too bright. So the camera is here, but the light is from the sky, then you don't see a face. Face is with a shadow, right? So then if there is a glass door and people are entering, then you don't look at only the people who are entering into your shop, but you also see people walking on the corridor outside, because glass is transparent. Then camera will notice the people who are walking outside without entering into your shop, but ultimately it tries to recognize those faces, but they are not enrolled faces. Then how do I detect some people who are not enrolled into the system, right? And so on. It's not only that you have to take up the attendance of the people whose faces have been registered, but you have to also say that this customer is not known to me, this person is unknown to me, and so on. So recognizing some real royal customer of your system. For University of Mysore, the chief minister may suddenly visit, then the surveillance camera, because chief minister, photos are available on web. Let the system download who is the chief minister, how does he look in different angles, and let the system automatically understand. And the moment all of a sudden, if minister If a minister happens to be step into my office, then system should give me an alert telling that, look, Dr. Guru, here is such and such a officer is coming into your office. Go and welcome him, right? Can we think of making the system so intelligent and spontaneously intelligent in learning something of its interest, right? That, I mean, you can relate this to a classroom attendance, teacher, recognition, and so on and so forth. Look at here, is a picture. A person is entering, gate is getting opened, and the door is getting opened. And how do I detect? It's an entry action. Entry action. I mean, you have to train a convolutional neural network to recognize the position of the gate at 10 degree, 15 degree, 20 degree, 40 degree, etc., 60 degree. Then person is moving. So look at this action. Door is getting opened and person is stepping into the shop. Has got to be modeled sequentially. It's not that your conventional convolutional neural network, a fully connected architecture would help you, but in addition to that, you have to get into a recurrent neural network, right? Recurrent neural network. This is an entry. This is not an entry. You have to distinguish this action from this action. This is an exit action, whereas this is an entry action. How do I detect these activities? It's a wonderful problem. Then only you can make your AI in reality, right? So these are some of the videos which we could capture as part of our NIMO activities for the purpose of making visual analytics possible in sport environment, finding out something interesting where person is because of slippery, falls down, and then crowd gets formed, and so on and so forth. Look, this has got to be spontaneously, instantaneously be detected, right? Then the corresponding alert should be generated. If nobody is there monitoring, then the system should send a signal to the owner of that code, and the owner can come and this is one should take care of that, right? Look at these are all the challenges, and especially instead of challenges, this is a camera health, and somebody may intentionally hide the camera, right? And that has got to be obscuring, we call it as that has got to be detected and correspondingly alert. Somebody may come and keep the kerchief on the camera, then camera should sense it and send a signal to the owner of the camera so that he will come and physically take care of it. That is what health issue related to camera could be obscured, camera could be shifted left, focus loss. These are all quite interesting natural phenomena which we have to first work as a pre-processing stages for to make video analytics possible in real time, in reality, I mean. So in case of personal protective equipment detection, we also worked on some PPE detection and safety alert. So probably here, generally the people who get into hard working environment, then we expect them to go with some jackets, safety helmets, right? In addition to that, they should not reach some specific dangerous location. Then correspondingly alert should be given to them, right? So detecting and seeing that these people are wearing helmets, wearing jackets, and if somebody goes near to this dangerous zone, it must be identified, detected. This is what. And look at this is quite interesting, scenario for you people. Look at the second one, please. So here is somebody, concentrate on this. Somebody is climbing up the ladder, like structure. Please concentrate on that, and then he suddenly falls down. It's not that I want my system to understand that person as as a person has fallen down, and that fall has got to be identified, and the alert should be generated. No, what is the reason for that? Why did he slip? So can that be identified? Had there been somebody, a owner of this business, standing here and monitoring? If some mystery like person is standing here and monitoring, this person is climbing up, he must have identified that and must have given a signal before he falls down, right? Look, be careful, it will happen now. So we must have given him an instruction. I want system to give such an instruction to a person before he falls down, right? So that's what. So automation of number plate, especially in look at the traffic density in Bangalore city. Counting vehicle, forget about it. Number plate extraction we are talking about. Can we do automation of number plate recognition, especially in this dense traffic, right? In this dense traffic itself is used, is not that. So it poses many interesting problems. One is, identifying different models of cars, how many cars are there, how many buses have gone within 5 minutes last duration, how many trucks have gone in between, how many cars, how many two-wheelers, and in case of cars, what is the model, make, etc., etc. And not only that, what are the number plates, licensed plates? Can we generate that? So that's quite interesting. We worked on that, and we are making, working towards making it reality, especially for this dense, traffic in Bangalore city. So look at the number plates are getting recognized and displayed here, right? Okay, this has put us into a more difficult environment. And there were many challenging issues, and we had to take care of perspective corrections, and then deploying convolutional neural network of different, or even for segmenting, for recognize. We are not thought of going with the OCR, right? But we just have gone with the detection algorithms using deep learning architecture to detect all English alphabets, all Kannada alphabets, all numerals, and so on and so forth. So that's alternative way of solving the problem. So this is another interesting, application use case which we worked on. Here is two gantry gates where trucks are entering here, may enter in one gantry gate, may enter in second gantry gate, and trucks are forming a queue. And my interest is to calculate what is the dwell time of every vehicle from here to here, from their entry into this area till exit. So one vehicle because queue formation and due to some reason, and whenever there is a rush of trucks coming in here, the queue gets formed. How many trucks are there in the queue? Count the queue line, and how many trucks are there? What are the types of trucks? What is the dwell time of the first truck? What is the dwell time for the second truck? And so on. Here is a dwell time, right? Dwell time calculation. And then what is the real pragmatic difficulties we found while working on this use case is that if there is a big buses, big vehicle passing through adjacent lane, they used to get detected. Somehow we could tackle it and solve it. Look, deep learning architectures are available for detection. YOLO tools are available for detection, but unfortunately that YOLO tool will detect all trucks here. But my interest is only those trucks which are passing through these gantries, right? Look at, these are the two gantries here. Hope you can see that, So my interest is to, any vehicle which is coming from any direction, but entering through these gantry gates, I got to detect only those trucks. But I should not end up detecting these trucks. If there is a big bus passing through, it is that, it hides our, trucks of interest. But in spite of it, we do expect our system to continue working without misclassification. Then if that is the case, then we used to have real pragmatic difficulties in tracking of the trucks with the support of trackers. Tracker used to get lost. Then one vehicle used to get associated with multiple trackers. Look at here on the other side, there was a vehicle which used to get a track number 3, a tracker number 4, tracker number 6. Then the question is to identify which are all the trackers IDs which are found to be equivalent. Then we went on with an equivalence class of, tracker IDs, and based on that equivalence class, we grouped the IDs and then calculated the total dwell time of individual track. So the total dwell time of this individual track could be what is the entry for the ID 3, what is the exit of ID 6. We need not to worry about entry and exit of ID 4 because it is the equivalence, right? Then take up the entry and exit time of ID 6 and subtract the entry time of ID 3, and that gives you what is called the dwell time, right? Look at these are, but still we have many more challenging issues. Environmental condition, we are not taken care of, night environment. If the environment is too shadow, too in case of rainy season, if it is too cloudy, then probably our detection may go wrong. And if there are vehicles coming through and entering through both the gate, then a kind of Y shape gets formed. In that case, what is the queue length of 1 and queue length 2, and what is the dwell time for each vehicle, and the truck classification, is that a car, is that a truck, a smaller, moderate sized, etc., right? So these are quite interesting problems which you work on. Look at, if I just display our solution, system has detected the vehicle, right? Look at ID 1 got generated for the same 0, but earlier it was 0, now it is 1, and it has become something like 2, right? Something like 2 is about okay, now it is ID 2. Look, here is a big bus is passing through, big vehicle is passing through, but in spite of it, we should not lose the tracker. The tracker generally used to get shifted to this bus and goes on. That should not happen. I mean, we have got to identify which are all the trucks passing through the adjacent lane, and those have got to be automatically avoided, right? These are all quite interesting, challenging issues when you want to make your AI in reality. If you really want to deploy your AI, if not work for real time, at least to make them real, working in real environment. So we can think of speeding up and improving the efficiency of the algorithms a little later, but see that they become reality first. Okay, so these are all the issues which we are going to. But the model which works in sunny time may not work in shadow time, may not work in cloudy environment. So then how to build a system which can which has got a redundant programming so that model will be shifted. I mean, ultimately it is look for a best hypothesis based on the environmental conditions. If the environmental parameters are also observed, and based on the environmental parameters I want to switch over from a program to a program, from a model to a model. I mean, it's not that my machine learning task is to identify a single hypothesis in the hypothesis space, but to work out possibly many hypotheses where each hypothesis suits a separate individual environmental conditions, right? So there could be many more interesting applications, especially when Android apps are considered. We have been talking about sign language understanding even in our laboratory. My colleague Dr. H.S. and Nagendra Swami also worked with a couple of students to solve this sign language understanding. Look at sign language understanding means there is a physically differently able personality who cannot speak out, but they produce a sign. I go with a Android, app. I capture the images while they are signing. Then my app, my mobile phone should speak out in English equivalent so that I can understand what they are signing. On the other hand, if I speak, then mobile has to capture my audio signal and produce with the support of graphics on the mobile cell phone the signs of my English sentence so that he can understand looking at it. This is what, but still we have not materialized it, though we have been working on this problem for the last roughly about 15 to 20 years, right? Though we have produced from our laboratory about a couple of PhD scholars who have completed their thesis work, but still making it reality is pending. How to make it? Can we think of Android based programming to make sure that system will work with mobile phone? Flower recognition in garden. I just go with my mobile cell, keep the camera on, and automatically my mobile phone should guide me. Look, Guru, are you searching for some Mysore jasmine? Right? Look, here is a Mysore jasmine suddenly, right? So this is, can I make it a reality? Yes, my team has worked a lot on flower recognition. We created a voluminous big corpus of flower recognition, flora, fauna, association between the flora and the fauna, which fauna goes to which flower, which flora, what eats what fights against what. This is quite interesting. I mean, keep the network of cameras, surveillance cameras, and if any animal moving across, tracking of the animal from camera to a camera in a network of camera, and then that animal may go and eat some plant. Which plant does it eat? If it is a buffalo, which plant does it eat? If it is elephant, what does it eat? Is there any relationship between a flora and a fauna? Can we think of automatic modeling of pathway of each fauna so that we can give kind of strategies, we can give kind of recommendations for urban development authorities of any cities in India? Online signature verification, strictly speaking, in my opinion, deploying deep learning and online signature verification is not at all required, because we have few number of reference samples to match against, but we want a powerful matcher rather than powerful learner. So look at online signature verification. We have also collected a very big data set of online and also offline for about 1,000 individuals of 50 different samples. But unfortunately, when we get into the banking sector, there will not be good enough samples to train deep neural network. We are going to go with the classical machine learning techniques, especially for online signature verification. There are many interesting opening issues. Like in our laboratory called DAL, Data Analytics and Learning Laboratory in University of Mysore, we have been pursuing this type of work for the last roughly about 20 plus years, guiding students, working on different domains of this data analytics, not only into visual analytics, but also into text analytics, audio analytics, right, image analytics, whatnot, natural language processing, including that. But we have been working on that. We are more in number, supervising people, working for varieties of problems related to this. If you want to have any guidance and any kind of training, you can approach any one of us. Probably the University of Mysore is so happy in extending support to train people who want to be well versed with the technology called AI technology. On the other hand, currently I am with associate with Nymo Technology on my sabbatical leave. I wanted to learn how the industry is really productizing the AI techniques, and I just wanted to know what is really going on in industry sector. Then I thought of going on sabbatical leave with Nymo Technology. I'm associated with the Nymo Technology appears to be good company which is concentrating, focusing its attention only on video analytics like face recognition, object detection, activity recognitions, ANPR, and automatic number plate recognition. Very focused domain. And having worked with members of the data science team there, I could present before you all a couple of interesting use cases. In summary, hope I am on right time to wind up my presentation. In summary, I just initially explained the science behind AI, the fundamental science of artificial intelligence, the machine learning, deep learning, and then subsequently keeping in mind COVID-19 opportunities and situations, especially also highlighted the challenges related to face recognition, which I really faced and worked on. And then activity detection, many more interesting activities videos I just have displayed, and PPE, personal protective equipment detection, safety detection of person, and recognizing number plates. Look, the problem in recognizing number plate, especially in Indian scenario, is not that the number of vehicles in the scenery is too many, and it's not that the quality of the pictures is too bad, or that there is a rainy season or the shadow of a vehicle, nothing. And most of the times, even if the vehicle number plate is completely, the area is completely visible, and it happened to be a car of a great politician who has just attended a meeting where he was felicitated, and because of his felicitation he had a garland and a lemon with a chili, and he has put it in front of the car, and that lemon and chili is actually hiding the number plate. Though the number plate area is completely visible, unfortunately our camera will go wrong, completely gets misled. So that is a real challenge. I mean, look at, dear friends, people are talking outside India, deployment of AI in real time, like driverless car. Look, even drivers are finding it very difficult to drive the car in Indian environment, Indian road, right? Then how do I make driverless car moving across in Mysore city, moving across in Bangalore city in such a dense traffic, right? Think of such difficulty. You being Indians, you being AI expert, working in Indian scenario, you have got many opportunities to explore and related challenges to face, and you can show up that you have done something great to the field of artificial intelligence. So I also presented one video on queue count of vehicle and vehicle tracking and well-time computations. And all in all, I think I have taken you for a walk of various applications involving AI-based solutions. With this, let me thank you, one and all. Thank you very much for your great patience listening. Thank you.
Thank you, sir. It was really a very interesting topic, and all the topics discussed are of real interest to AI research community. Researchers can pick up the problem of interest, and they have got to think about the way complexity gets solved in human brain in perspective of cognition, identification, classification, and recognition. Really appreciable, sir, for the accuracy achieved by the proposed model. And we have some questions from the
Sure,
participants, sir.
sure, sure.
So the first question is by Dr. Chandrakala HT. Madam wants to know the mask face recognition system, which tool was used to calculate the difference vector for feature ranking?
Mhm.
Could it be calculated using the deep learning model, which was deployed
Actually,
for recognizing faces without
yeah,
masks?
we just have taken a deep neural network, and then we just have detached the fully connected component of that, right? We explored on different models, right? So we just have detached that fully connected part of that, and just ended up extracting only 128 features. After then we just have done feature analytics. So deep neural network or deep architecture has not been used for calculating differences in vectors between face with a mask, face without a mask. No, what we have done is we just use deep architecture with a fully connected component to train, and then we just have detached that part and have taken the 128 dimensional vector for further feature analytics, and that further feature analytics is done with a conventional mechanism, no deep learning.
Yes, sir. And the second question is it iris recognition work better if person wears mask than the face recognition system?
So iris recognition, probably most of the people hesitate giving iris data, including myself. So why we are talking about face recognition is that without even bringing it to the notice of the person, we can capture the face, but not the iris. That person has to cooperate in capturing iris data, right? Iris recognition accuracy is totally different. Iris data is almost like fingerprint data, but both the fingerprint and iris data are with the support of with the coordination of the individual, right? But most of the times I hesitate, that especially in COVID situation, I hesitate touching anything, right? Including I hesitate touching my right hand with my left hand, right? I always try to keep both the hands as much as social distancing, right? Even within my hands, right? This is a COVID situation. We cannot think of any sensor where the customer is or the individual is supposed to touch and give the data. So the best modality is the face recognition, right? So then the question now is, how much is the discrimination ability of an individual face? Only one eye area, not the iris data, but the only eye area is concentrated, right? Okay.
Yes, sir.
Obviously, iris data is more powerful in authentication. That's a different biometric. But here in face recognition, instead of looking at the entire face of a person, if we look at only the eye area of a person, the top half of the person face, what is the recognition accuracy, right? Or in the other way around, it is to make a study on what is the discrimination ability of an individual face, especially the eye area across population of many people, thousands of people, not one or two. I mean, my interest is to know how much is the top area of an individual face capable of discriminating that particular face from the rest of the thousand faces, right? Okay, how much is the ability of this mouth and nose area of a face in discrimination that respective face from that of the remaining of thousand faces, right? So then, I mean, you can think of a deep neural network, a deep architecture where instead of integrating the entire 100 by 100, 10,000 pixels together to work out 128 dimension feature vector, if you can think of, going with preserving the locality information, left eye area, right eye area, nose area, mouth area, if we can think of, deploying individually deep learning architectures and then extracting, interesting features from each locality and then fusing them together, probably that would help you in, accomplishing better accuracy. I mean, time being, when you go with a deep neural network architecture, any topology for that matter, when you give 100 by 100 images in input, the set of features which will be generated out of that architecture is every feature of that, will be a function of all entire global, but not local. Then we are going to change in the architecture. You are going to come out with your own architecture. It's not that you are going to exploit the beauty of existing architecture. For an academician, there is an opening for you. Can you think of an architecture which concentrates on bifurcating these areas of a human face into individual components and deploying parallelly different deep architectures and then finally fusing them for fully connected classifier, where even in fully connected classifier, I don't want classifier to work by integrating them, but I want classifier to think of generating label for individual local area and then assimilating the generated label for ultimate label. That could be an opening issue for a person who has been pursuing research in the area of deep learning, right?
Yes, sir. And we have one more question. It's from PS Mandya. Is it given that anything which involves image processing, deep
Hmm?
learning algorithms provides best solution?
Not necessarily. I told you somewhere, I mentioned in between. Don't think that every task can be solved effectively only when you go with a deep learning, right? Sometimes conventional classification algorithm, you know, classical classification algorithm, I would rather love to call them as, right? That classical, machine learning algorithm would work wonderfully well when compared to deep architecture also. But it is in your hand to make a study, have a domain knowledge, and check which one. That's what is called a searching problem in hypothesis, right? One is hypothesis space, making, consisting of only those solutions made up of, classical pattern recognition approaches, classical machine learning approaches. Another one is hypothesis space where which is in more, which is integrating only those deep architecture space and search for a better model, right? That is interesting avenue for academician especially. But industry people don't bother about it, right? They want quick solution. But on the other hand, academician has to give it a thought and explore possible ways of combining the hypothesis space of both classical machine learning and a deep learning, right?
Yes, sir.
Yes.
And we have another question. Can
Mhm.
AI be used to diagnose health related issues? And
Yeah,
will it replace the doctors a day?
no, I told you already, somewhere, please, dear participant, don't think that we are looking at AI model to replace anybody for that matter. Nobody can replace me in giving lecture, looking at students, right? Nobody can replace anybody, including doctor, me, teacher, right? An engineer, a policeman. Of course, we are talking about ANPR, automation of traffic, monitoring. No, nobody, nothing can replace a policeman. But we can think of a AI technique as a supplementary. It can make me more effective. Your diagnostic tool, AI tool, can make doctor more effective, can make doctor more efficient, right? Okay, it is a kind of added strength to the doctor, not a replacement for a doctor, right? I think somewhere I mentioned it without missing it. So most of the times we just miscarry that. Yeah, ultimately we are talking to replace human individual. No, nothing like that. Okay, and most of the times we have illusion that, because of this AI technology, jobs are taken away. No, it has introduced more number of jobs of higher level than a lower level jobs, right? Okay, so cleaning of data, preparing data for your domain application has created many jobs for people of graduation, right? Okay, please don't carry, after hearing anybody's lecture on AI, that AI is a tool for replacement. No, sorry. It is a supplementary tool. It is only to supplement your activity. It is only to support your activities, to make you more effective, to make you more efficient in accomplishing a job. Okay?
So, the last question, sir.
Fine, fine.
So, which is the better algorithm for activity recognition for video data deep learning,
Uh-huh.
whether neural network or SVM model?
See, don't misunderstand between these two. SVM is a kind of classifier. Neural network, a fully connected, is a kind of classifier, right? A neural network fully connected with a convolutional neural network which combines both feature extraction and a classifier. But in case of SVM, we have to decide manually which are the best features to be fed into the SVM, right? If you go with a deep learning architecture for activity detection, probably you need not to worry about what are the features to be extracted, because the system automatically decides, automatically adjusts. Look at, there are so many weights to be adjusted. As the number of weights increases, the dimension of the hyperspace also increases. The moment the hyperspace gets expanded to a larger domain, larger area, then the chances that you hit the most optimized solution is very high. That is what is the beauty of deep learning architecture, right? So for any activity recognition, if you don't want to worry, if you doesn't want to take any risk on deciding upon the features, I would rather advise you to go with the deep architecture instead of going with support vector mission. Because for support vector mission, we have to extract features first, right? You have to do feature analytics. If you don't want to take that risk, you go with deep architecture. If you want to take up that risk and then thinking of possible features, combining them, deriving something out of it, which are more rich in discrimination for activity, detecting an activity like a person running, means you have to extract something out of that running activity which are capable of discriminating the rest of the activity. That's all the difference, right? So if you can take up the risk of finding out the best features which can model that activity, universal, then fine, you can go with the support vector. But support vector machine is known for its own strength in accomplishing better classification accuracy. There is no second thought in it. But still, deep learning architecture really do wonder for any applications as long as your domain data is relatively big. You have sufficient large number of samples to establish a mapping between input and output space. If that becomes as exhaustive as possible, and if you have good enough time to train your model, I would rather advise you to go with deep learning.
Thank you, sir. On behalf of BNM family, we extend a very grateful thank you for accepting our invitation and delivering this talk on our online webinar series. Thank you very much, sir.
Thank you. Thanks for the opportunities given. Thanks a lot.
Thank you, sir.